Alrighty. Here's our essential question for today. How do I find the experimental probability get some good long words here. Probability of a simple event. Oh, all right. Now, last section we talked about probability. Probability is a number that's between 0 and 1, always. Okay, so from 0 to 1. We write it either as a fraction, sometimes as a decimal, sometimes as a percent. And so when we talk about experimental probability, I'm going to write a big fraction here. And then we'll describe what's the numerator and what's the denominator. Here we go. Numerator, I'm going to use the hashtag symbol to stand for number. The number of times an event occurred. I guess I got to make my fraction bar a little longer because I write so fast. And the denominator is simply the total number of trials. And I'm going to use that hashtag abbreviation for number because in my generation, that's what it was. Just stood for a shortcut way to write number. All right. A simple event refers to something where there is only one outcome. And this would be for an event if you want to add that on there. And last but not least, simulation. So here's what happens. Sometimes we have an event that's really difficult to actually do the experiment. And so sometimes what we have to do is substitute a simulation. So this is some sort of model, some sort of experiment that we're going to use that is going to model this difficult one. So we're going to take this model and we substitute for a, let's say, a difficult or complicated event that's a lot more challenging to replicate. All right. Now, these first ones are going to go pretty quick because I think these are very intuitive. And whenever you do these, oftentimes we'll say, hey, just write it as a fraction, but make sure your fraction's in simplest form, okay? If it gives you directions to write it as a decimal or as a percent, then do so. But if it doesn't specify, let's just leave it as a fraction. Martin has a bag of marbles. He removed one marble at random, recorded the color, and put it back into the bag. He repeated this process several times and recorded his results in the table. Find the experimental probability of drawing each color. So this was the experiment that he performed, all right? Red was 12, blue 10, green 15, yellow 13. In order to find this fraction, he got red 12 times out of the total number that he performed the experiment. So what we need to do is add this total together to get these, all right? 7, 10, carry the 1, 2, 1, 2, 3, 4, 50. Nice. All right, so 12 50ths was the experimental probability of getting red. That's not in simplest form, so please write it as 6 25ths, okay? Boom. By the way, that's the same as 24 hundredths as a decimal, 24% as a percent. All right, do the same with blue. And that's supposed to be 0. 10 50ths, which is 1/5 in simplest form. Green, 15 times that he got a green one, out of 50. That also can be simplified to the fraction, let's see, divide by 5, 3/10, okay? Which as a decimal would be 0.3, and then it'd be 30%. Last but not least is yellow, 13/50ths, and that one's in simplest form because 13 and 50, no common factors. All right, so really most of these are going to go super fast, super simple, and you plow through those, okay? But turn to the next page because this is really what I want to talk about. And this is the part about using a simulation, okay? Now here's what happens. It says the baseball team has a batting average of .250 so far this season, 250 thousandths. This means that the team's players get hits in 25% of their chances at bat. Use a simulation to predict the number of hits the team's players will have in the next 34 chances at bat. Okay, so here's what we've got to do. We see that their batting average is 25% or 250 thousandths, which is the same as 1/4. Because getting the whole team to actually do this, and we just want to run and get a prediction, we're going to make up a simulation that has the same odds, but is going to be a lot easier for us to perform. So what they're suggesting is, hey, let's pick a deck of cards because cards have 4 suits, hearts, diamonds, spades, clubs. And since 1/4 of the cards are hearts, we're going to let hearts represent getting the hits, and then the other 3 suits, diamonds, clubs, and spades, represent not getting a hit. Okay? So get your pencil ready, and we will run this simulation together here. I've got my random screen generator that we're going to use, and we've got to keep track of 34 of these, okay? 34 times we're going to come up with this simulation. So I've got my little simulator here that says hearts, diamonds, clubs, and spades. And what we're going to do is kind of run this 17 times, okay? So here we go. I'm just going to start running this, and I'm going to need you to keep track with tally marks in that frequency table that is right. I was scrolling through Reddit earlier today, okay? And I saw this really interesting quote. So here's where you're going to be. I'm going to run this generator on the screen, and you keep your tally marks. All right? I was trying to minimize this a little bit to see if I could get this to work. It says restore. Yeah. For some reason, this just doesn't want to work. So you're just going to watch this screen. I'll keep tally on my sheet, and when we get all done, we'll make sure we've got exactly 34. All right? We're not going to count this first one that says spades. We're going to start now. Okay? So here we go. First one, diamonds. Put a tally mark there. All right? And then we'll do like 4 in a row now. Clubs, hearts, spades. Okay, so I'm going to go clubs, hearts, spades. So right now you should have 1 on each of the 4. Clubs, spades, clubs. So let's go clubs, spades, clubs. Hearts, spades, hearts, spades. Let's keep it going here. Diamonds, spades, diamonds, spades. Diamonds, hearts, diamonds, hearts. Clubs, diamonds, club, diamond. Spades, clubs, spades, clubs. Hearts, diamonds, hearts, diamonds. Hearts, diamonds. Okay. spades. Clubs, ba-doom. Come on, diamonds. All right, so let's stop here for 1 second so I can kind of keep track of where we're at. So right now, here's what you should have for tally marks. Under the hearts, we've got 1, 2, 3, 4, 5. Diamonds, we've got 1, 2, 3, 4, 5, 6, 7. Clubs, we've got 6. 1, 2, 3, 4, 5, and 6. And spades, we also have 6. There's 4, 5, 6. All right, 6, 12. 7 more makes 19. And these 5 make 24. We have to do 10 more because we need to perform an experiment that has 34 in it. All right, so let me flip back to the screen, and we've got to do 10 more. Here we go. Choose. All right, so we've got spades, that's 1. Hearts, that's 2. Diamonds, 3. Come on. Diamonds again, 4. Spades, 5. Clubs, spades, hearts, hearts again, clubs. All right, I'm going to stop and do a little update here so I make sure that we're being accurate. So right now I'm at hearts has a total of 8. Diamonds has a total of 9. Clubs has 8. And right now spades has 9. So we have 9 and 9, that's 18. And 8 is 26, and an 8 is 34, I think. Let me double check. 5, 10, 15, 20, 23, 4, 5, 6, 7, 8, 9, 30, 31, 32, 33, 34. Bingo. Here's what we've got. So let's write these down. 8, 9, 8, 9. That turned out to be pretty well balanced. That's pretty good. So now, because we did this simulation for the baseball team, it says since there were 8 hearts, you can predict that the team will have 8 hits in the next 34 at-bats because this simulation represented our experiment. The total was 34, so the experimental probability would be 8 out of 34, which technically in simplest form would be less, but since we were talking 34 at-bats, we'll leave it there, okay? So in general, when you are finding experimental probability, again, you just find the number of times the event occurred I didn't spell that right, over the total. Simplify the fraction. Remember, it's always between 0 and 1, where 0 is impossible and 1 is a guarantee. Check Schoology for your assignment is in the textbook. Good luck. May the force be with you.